Up next, we have Andrei Runov.
So thank you very much for this opportunity. My goal today is to inform you about current status of the THEMIS ARTEMIS mission, which we'll just mention, and to share with you some ideas on how we can use ARTEMIS measurements along with the Hermes suite and potentially lunar surface assets to address some interesting and compelling science questions. So first, a little bit about Artemis mission. Well, in our genealogy, Artemis is the daughter of Themis. THEMIS was the 5 spacecraft mission to study essentially magnetic substorms in the magnetosphere, the Earth magnetosphere, and starting at 2009, the 2 of outermost THEMIS probes were sent to the deep space, and finally at 2011 were injected into stable lunar orbit with roughly 26 hours period and 100 kilometers to 19,000 kilometers altitude from the lunar surface. With the moon, the Artemis spacecraft spent most of the time in the solar wind, and 3 to 4 days every month in the Earth magnetotail. Deep Space Network became available for us in 2013, and it allows us to downlink large percent of our data in the highest possible resolution. Due to mission biased, so to speak, we bias to the magnetotail, and we have 70% of the magnetotail data in highest resolution, and some interesting events like lunar wakes in the solar wind in highest resolution. But it's programmable, and we can change it if request will be sent to us. In terms of data coveraging so far, we coverage almost entire solar cycle 24, and in this yellowish box I highlighted the interval when the highest resolution, the Deep Space Network, is available and allow us to have a data with highest time and energy and angular resolution. Okay, a little bit about our measurements. The Artemis mission consists of 2 spin-stabilized equatorial orbiting probes equipped by flux gate magnetometer, which allows us to measure DC magnetic field with resolution 4 to 120 vectors per second. Such coil magnetometer to allows us to measure AC field up to 2 kilohertz Nyquist. Electric field instrument, we have 4 double probes in the equatorial, in the spin plane and spin axis plane. Also, we have the suite of particle instruments, which includes the electrostatic analyzer to measure ion and electron fluxes from first electron volts to tens of kilo electron volts. So it's subthermal thermal population with resolution for 3D distribution function for second, and a solid state telescope here, which measures electron and ion fluxes from roughly 50 kilo electron volts to first MeVs for electrons, and again from 50 kilo electron volts to up to 10 MeV for ions. Again, time resolution is 4 seconds. The data, all the data are publicly available at ARTEMIS site at Berkeley, and also from their SPIDOS system, including our new Python-based version. So SPIDOS mainly based on IDL, which not really convenient for many of us. Now we have a Python-based version, which is much more convenient for our community. So here is our web page. It's
About 2 minutes left.
okay. So here there is if you click to the data, you can see the summary plots of the mission. It's a really dense plot, but quickly, first two panels show the geophysical content. The next panel shows magnetic field, then density, ion density, velocity, ion and electron temperatures, and ion spectra from solid state telescope, electrostatic analyzer. You see the solar wind beam here, and spectra from solid state telescope, electrons and ions. And two bottom panels show the waves from electric field and search coil magnetometer. It's just arbitrary example. It's just 2 days ago. But you may see that in this situation, ARTEMIS probe moves from solar wind to the magnetosphere. It's an interesting example. And about perspectives and what we can do. So near moon environment is unique plasma laboratory, and multi-point observations will allow us to study very interesting regime in plasma physics, in weak, highly fluctuating magnetic field with strong gradients like current sheets, solar wind discontinuities, flux ropes, reconnection jet fronts, etc. With the lunar gateway Hermes suite, we can do 3-point measurements, as Will mentioned, earlier. So ARTEMIS probes are equatorial orbiting, while the gateway will be polar orbiting. So that allows us to have 3-point measurements with highly varying interspacecraft separation, which allows us
About
to
30 seconds left.
Yep. I'm finishing. It's my last slide. So it's a really interesting opportunity for us to study characterization of electromagnetic lunar environment and particle acceleration in contexts of surface-based observations. Lunar ARTEMIS and Hermes will provide information on electromagnetic and plasma conditions in near moon space. And what we will be interested, first of all, in this context is mapping to the lunar surface, which requires surface measurements. Yes, I guess I should stop at that point. And if you have any questions, please ask me.
We're actually out of time for questions to be asked right now, but if you have questions for Andre, please put them in the chat, and Andre, you can answer there. That would be great. This is really exciting, and it's always nice to see the original Artemis show up and present how they're able to help with the new Artemis as well. So
Thank you.
always great fun, although slightly confusing sometimes.